My name is Ethan, and I, together with Guy, the software chief, are the state machine crew in Everglow 1900. A state machine is a coding mechanism which enables the robot to do 2 tasks at a time in the autonomous period of the tournament. In the driver period, the robot can already do 2 tasks at a time, because every millisecond it gets all the input from the controller, which can be from multiple buttons or joysticks. For example, driving straight while lifting the elevator, or moving the far bar while opening the claw. Why is it important, actually? Well, speed and efficiency are key in the robotics competition, whether in picking up cones, dropping them onto junctions, or moving around. Doing 2 or more tasks at once, instead of waiting for the first task to finish, and only then executing the second one, saves a lot of precious time. A state machine is one of the only ways to do 2 tasks simultaneously, and the most organized and modular way. How the basic mechanism works. In a codebase without a state machine, each system is initialized in the telop itself, while with a state machine, they are all initialized in an enclosing class, and that class is initialized in telop. That enclosing class is named the system coordinator. It contains a public constructor, which takes the op mode and initializes all the classes, and a tick function. The tick function. The state machine takes all the functions all the systems are currently executing and restructures them in a way that simulates a driver's input. Although the robot is still executing the same functions, it does so in a jagged manner, only doing one step or one tick at a time. If more than one task needs to be done, each telop loop cycle, a step of each task will be performed, resulting in the 2 tasks operating simultaneously. The tick function does so by running a method named tick, which is present in all the states. But what are actually the states? Each system has a state variable, which contains the state that system is currently in. That state could be the resting state, or an acting state defined in the system. The resting state's tick method does nothing, but the acting state's tick methods do something until a target is reached. Then they revert the system state to the resting state. All of them are based on the state interface in order to utilize polymorphism in the tick function in the system coordinator. The basic states. There is a state interface, which contains an enum message, which is used to broadcast to all the systems when one system is done acting, and the basic abstract tick method. And the resting state contains the implemented tick method, but it does nothing. Here is a more complex state. It is the acting state of the claw system. You can see in the constructor over here, it takes a final state to reach and a velocity at which the motor should move, or the servo in the claw. With them, it calculates the total movement time the movement should take and starts a timer. In the tick function, it checks if the total movement time is smaller than the time already passed. If it is, that means the claw has reached its desired position. And then the state of the claw system gets set to a resting state, so it does nothing. And the system coordinator broadcasts a message which tells all the other systems that the claw is done, so they can start moving if they are dependent on each other. If this condition is not reached, which means the claw hasn't reached its desired position, then the claw moves just a tiny bit by the start position plus the velocity times the time already passed. A part of using each state independently, there is also an option to use a sequence, which allows adding multiple tasks to itself and running them one after the other. This functionality is very important for the robot's physical stability. Moving the far bar while moving the elevator can cause the robot to lose balance and fall over, rendering the game a loss. This is a portion of the sequence class. You can see on the left it contains a static subclass called sequence item, which is used to create an item in the sequence. And on the right there are 2 functions, methods, named handle message and handle continue. These methods handle moving through the sequence, basically. Here are a few examples of using a sequence in a telop. For example, this is a sequence being used to prep the robot. You can see it moves the claw to the open position and moves the far bar to the pickup position. Another example would be to move the far bar right after the elevator finishes moving. You can see the elevator moves first to the high position, and then the forebar moves to the pickup position. Summary. Efficiency is key in the first Tech Challenge tournament. A state machine helps control all the tasks the robot has to do in the autonomous period and organizes them. By using the system coordinator class, we can efficiently control all the tasks the robot has to do. By using a sequence, we can prioritize some tasks over others and make them execute first. I hope I managed to convey why the state machine mechanism is so important to the autonomous period of the tournament in terms of efficiency and playing speed. And I hope to see you guys on the field.